Space doesn't just surprise us, it breaks the rules. Across our galaxy are planets so bizarre, so extreme, that they seem to defy everything we thought we knew about how worlds form. Tonight, we dive into the impossible. Lava oceans that never cool, planets with rings wider than stars, worlds that rain metal, and rogue planets drifting alone in the dark. These are the planets that shouldn't exist. From hot Jupiters skimming the faces of their stars to super puff planets lighter than cotton candy, this is the wild frontier of exoplanets. Welcome to Deep Space Vault. Let's begin. Hot Jupiters, gas giants on the edge. Gas giants are supposed to form far from their stars, where it's cold enough for gas to condense. But hot Jupiters broke that rule completely. These are Jupiter-sized planets orbiting closer than Mercury, so close that a year can last less than a day. They're blasted by stellar radiation, their atmospheres superheated, their skies swollen and boiling. Some hot Jupiters are even inflated, puffed up by the star's energy until they're larger than physics should allow. They shouldn't exist where they are, and yet they do. Astronomers think they formed far away and migrated inward, pulled by gravitational tides or disk interactions. But how they survived that journey without being torn apart, that's still a mystery. 2. Ultra-short period planets, worlds with day-length years. Now imagine a rocky planet like Earth, but so close to its star that a full orbit takes less than 10 hours. These ultra-short period planets are scorched from head to toe. Surface rocks may vaporize into mineral atmospheres, while oceans, if they ever existed, evaporated long ago. Some of these worlds likely began as bigger planets, their outer layers stripped away by the star's gravity and heat, leaving behind a naked core, a world that shouldn't have survived the fire. 3. Lava worlds, oceans of fire. On certain planets, the heat never ends. Picture a world tidally locked to its star, one side always day, one side always night. On the day side, oceans of molten lava, where mountains drip and rivers glow. The atmosphere itself may be rock vapor, silicates, and sodium blasted into the sky by sheer heat. On the night side, that vapor condenses and rains stone, forming a cycle of rock weather that defies imagination. These worlds challenge our understanding of geology. Can continents exist where everything is liquid? Can mountains survive when the ground beneath them flows? Lava worlds say, yes, but not for long. 4. Iron rain, the planet that melts metal. Some planets host a weather report that reads like science fiction. Evenings of evaporated metals, mornings of iron rain. On the blazing side, temperatures vaporize exotic elements. Strong winds carry those vapors into the cooler night. There, they condense, and metal falls from the sky. For atmospheres to cycle metals, for temperatures to shatter the periodic table, these planets seem physically absurd. But the universe doesn't care what we think is reasonable. 5. Super puff planets, cotton candy giants. Imagine a planet larger than Neptune, but with the mass of Earth or less. These are the super puffs, worlds so fluffy their densities rival cotton candy. How do they hold on to such enormous atmospheres? How did they avoid collapsing under their own weight? And why didn't stellar radiation blow those atmospheres away? These planets likely formed in cold regions, then expanded due to internal heat or trapped starlight. Some may be wrapped in dusty, hazy shells that make them appear even bigger. They shouldn't be stable. They shouldn't stay intact, yet their ghostly atmospheres tell another story. The universe is very good at making improbable things. 6. Stripped cores, the skeletons of giants. What happens when a gas giant wanders too close to its star? Its atmosphere can be ripped away, leaving behind a dense, rocky core. A planet that looks like a super-Earth, but is actually the exposed heart of a former giant. These stripped core planets are fossils, proof that worlds evolve, decay, and survive in completely different forms. They rewrite the rules of planetary lineage. A world can be born as a giant and die as a rock. 7. Circumbinary planets, worlds orbiting two suns. Two stars circling each other is chaotic enough. Now place a planet around them, orbiting both, like Tatooine brought to life. Circumbinary planets shouldn't be able to form easily. The gravitational dance of binary stars can shred disks and prevent stable orbits. And yet, these planets exist, quietly tracing paths around two suns, surviving in regions of dynamic chaos. They remind us that stability can emerge from complex motion, and that planets don't need calm to thrive. 8. Rogue planets, worlds without a home. Some are cast out, flung into interstellar space by the gravitational violence of their birth. These rogue planets drift alone. No sunrise, no seasons, only endless night. Without a star's warmth, they should be frozen solid, but some may carry internal heat or even subsurface oceans warmed by radioactive decay and pressure. A living world in the dark. It shouldn't exist, and yet, maybe it does. 9. Mega-ringed worlds, rings wider than the sun. Imagine Saturn, but beyond comprehension. A planet with rings so vast they'd span distances wider than the diameter of the sun. These rings could be made from moon-sized fragments, dust and ice, remnants of shattered satellites or recent collisions. They shouldn't last long. Gravity and starlight should erode them. Yet the universe allows brief wonders, cosmic fireworks frozen in time. Planets with colossal rings challenge the limits of planetary architecture and our sense of scale. 10. Worlds on impossible orbits, the far, the tilted, the wild. Some planets orbit far beyond Neptune-like distances, too distant to have formed where they are. Others circle on extreme tilts at wild angles relative to their stars, or charge through highly elongated paths that bring them dangerously close every few centuries. How do these worlds survive tidal tearing? How do they keep their orbits over billions of years? The answers lie in stellar encounters, past migrations, and violent gravitational history. These worlds are the scars of cosmic events, survivors of chaos that never should have produced stable planets. 11. Diamond worlds, carbon planets in the dark. Some stars and systems are rich in carbon. If a planet forms there under the right conditions, high pressure, exotic chemistry, it may host carbon-rich interiors, potentially with layers of diamond. Do diamond worlds exist? We don't know for certain, but some planet compositions hint at unearthly abundances of carbon. A planet built like jewelry is absurd, and yet, chemistry does not care what we find elegant. 12. Water super-Earths, oceans deeper than imagination. Worlds can be made of water, not just covered in it. Imagine a super-Earth with hundreds of kilometers of ocean above layers of high-pressure ice, above a rocky core. No continents, no land. Only a global ocean deeper than any trench, any sea, any human dream. Can life exist there? What chemistry unfolds without continents, without weathering, without carbon cycles like ours? These worlds challenge our idea of habitability. They're not Earth-like, but they might be lifelike in their own way.
13. Atmospheres full of surprises. Carbon dioxide, water vapor, sodium, metal hydrides, and more. As our telescopes grow more powerful, we can read planetary atmospheres, detecting carbon dioxide, water vapor, sodium, metal hydrides, and more. Some planets show atmospheric chemistry that seems impossible for where they are. Unexpected molecules that hint at formation elsewhere and migratory pasts. We thought planets were simple: form, settle, orbit. But many are travelers, born in cold, living in heat, carrying the fingerprints of their journeys.
14. Planets in perfect resonance, harmony in the chaos. In a few star systems, planets orbit in near-perfect rhythm, ratios like 3:2:1, where each world tugs on the others in a cosmic symphony. Resonant chains shouldn't survive the violent birth of planetary systems. They should break. And yet, in some places, they remain, clockwork worlds that kept balance through billions of years. They teach us that order doesn't only emerge from calm, it can be forged in precise mathematical tension. 15. The planets that shouldn't exist, but do. Each of these worlds breaks a rule. Gas giants too close to stars, rocks orbiting in hours, atmospheres that rain metal, rings wider than stars, planets with no suns, oceans deeper than thought, chains of perfect resonance. They shouldn't exist, but they do. Every impossible planet we discover rewrites the textbook. They remind us that nature is more inventive than our theories, and that our models, like our maps, are never the territory. The universe is astonishing, not because it is understandable, but because it is stranger than we imagined. Planets that shouldn't exist, exist. They burn, they rain, they drift, they echo with impossible rhythms. And they challenge us to keep asking, what else is out there? If you enjoyed exploring the bizarre and the beautiful, subscribe for more cosmic documentaries. And remember, in space, the most unbelievable worlds are often real.